Hello, grade 9. So this week we are starting with a new chapter, chapter 8, called Resistors. So let's start. So these are the objectives that we're going to cover during this week's lecture. So you guys will be able to define the resistance of a resistor, to measure the resistance of a resistor, and to verify Ohm's law experimentally. Now, what is all of these about? Let's find out. Okay, so let us consider these two circuits. This is the first circuit and this is the second circuit. Now in the first circuit, let's see, it consists of a dry cell, a switch, a closed switch, connecting wires, a lamp, and an ammeter. All right, so we can see that the lamp is lit, all right, and the ammeter reads 0.9 amperes. Let's look at the second circuit. It consists also of a dry cell, a closed switch, some connecting wires, a lamp, and an ammeter. But we have an extra component here, which is, I don't know, its name is X. Okay, so this is like an unknown component. But what is the difference between these two circuits? What can you see? Like, what is the role of this component in the circuit? Let's look at the reading of the ammeter. In the first circuit, it was 0.9, but in the second circuit, it became 0.45. So when I inserted this component in the circuit, the current in the circuit simply decreased. All right, how about the brightness of the lamp? You can see the lamp here is shining so bright, whereas the lamp here, it is still glowing, but not as bright as circuit 1. All right, so let's simply put what we said into a table. Okay, so let's fill out this table. The first row, it represents the current, the intensity of the current that is passing through the lamp, which is the value that I actually read of the ammeter. And the second one, it represents the brightness of the lamp, okay, how much it is glowing. So the intensity of the current passing through the lamp before introducing component X, it was 0.9 amperes, and after introducing component X, it became 0.45 amperes. So the current that is passing or flowing through the lamp, it decreased. How about the brightness of the lamp? It was more before introducing X, and it was less, it became less after introducing X. So what is the role of this X component in the circuit? So from the circuits in the previous page and the above table, we deduce that X decreases the brightness of the lamp by decreasing the current passing through it. Okay, so it decreases the brightness of the lamp by decreasing the current that is passing through it. This X that we're talking about is actually called a resistor. So what is a resistor? From the name of it, resist. Okay, so it resists the electric current in the circuit. This is why the electric current, when the resistor is introduced, the electric current decreases. Okay, so it is an electric component, just like a lamp, a motor, a dry cell. We have something called a resistor, and it has two identical terminals. So the two hands of a resistor, they are identical, just like a lamp. We don't have a positive and negative terminal. We don't have a V and COM terminal. No, both terminals are identical. They are the same. So if you simply reverse them, nothing will change, nothing will happen. Now, the opposition of the electric current in the resistor leads to the liberation of heat, thermal energy. So we said that a resistor, it resists the electric current. Now, due to this action, due to the resistance of electric current, something will happen with the resistor. It will lead to the liberation of heat. So the resistor will simply warm up. Okay, so any electrical appliance you have at home, whether it's your phone or your laptop or anything else that you can feel the heat coming out of the device, okay, you can see that it simply heated up a little bit, it means that it contains a resistor. This happens due to the existence of a resistor, because a resistor simply it transforms this electric energy that we give it to it, okay, and into thermal energy, into heat. So this is why you feel it heating up. Now, what is its symbol? This is the symbol of a resistor. It is simply like a small rectangle with a letter R in it, or you can do it like this, like a zigzag line. Okay, so this is how we represent a symbol, how we represent a resistor in an electric circuit. Now, this resistor is characterized by its resistance. Not all resistors are the same, they are different. How can I distinguish between one resistor and the other? Simply by their resistance. So each one will have a different resistance. This is actually a value, it's a number, okay? And also one more thing is that the resistor of high resistance opposes more current. So if the resistance is really high, it means that the current it opposes is much more. So I will have less current flowing in the circuit. And if the resistance is low, it means that I will have more current in the circuit because it didn't oppose much current, okay? So yeah, the resistor with high resistance, it simply opposes or resists more current. Okay, so we can see we have so many cars. The cars in this figure, they act as the current. Okay, so the current is flowing through the circuit. The road is the circuit. And we can see we have like a little checkpoint right here where not all cars are allowed to pass. Okay, so the road is a bit narrow right here. This narrow road right here, it represents the resistor. And you can see how it doesn't allow all the electric current to pass through normally. No, it tries to resist it such that little current can only pass through. Okay, so it tries to resist the flowing of electric current. Okay, so this is like a resemblance or like a visualization of the process. Okay, so a resistor is characterized by its resistance. How can I measure this resistance? I know that a voltmeter measures the voltage, an ammeter measures the current, and now we will know that an ohmmeter, it measures the resistance. Okay, so it is the same multimeter. Instead of using it for measuring the voltage or using it for measuring the current, we can use it to measure the resistance. Okay, so if we use this section of the multimeter, then we will be using it to measure the resistance. So an ohmmeter is a device used to measure the resistance of a resistor. The ohmmeter should be connected in parallel across the terminals of the resistor in any order. So now polarity is not important. I know that it has two terminals, the com terminal and the omega terminal. Okay, so this symbol right here, it is an omega symbol, okay? It's called omega. So we have the com terminal and the omega terminal. But it doesn't matter where do I put them, okay? Because a resistor, it has two identical terminals. So it will give me the same value. It will give me a positive resistance. Now, a little note here, for us to actually measure the resistance of a resistor, the resistor must be removed from the circuit. So I must remove the resistor from the circuit and then I can measure its resistance. But once it is in the circuit, I cannot use this to measure the resistance. Okay, so we must remove it from the circuit and then measure its resistance. Now, the symbol for this ohmmeter that we're talking about, I used it here. So it is like this. Instead of having a voltmeter or an ammeter, now we have an ohmmeter, okay, which looks like that. We have different units for the resistance of a resistor. The SI unit is ohm. Okay, so it has the symbol, as we said, of omega. So this is the SI unit, but we have other units that can be used. I have mega ohm, kilo ohm, milliohm. Okay, so we multiply by 1,000 going from left to right, and we divide by 1,000 going from right to left. Now let's click on this and see how an ohm meter works. Okay, so this is the multimeter. For me to use it as an ohm meter, I need to use this section. So let me choose simply a scale, 20K, or we can use 200 ohm. Okay, 200 ohms. So we can see that it is connected across a resistor. It is connected in parallel. We can see that I have two common terminals between the two, and yeah, and the resistor is not in a circuit, so we simply isolate the resistor, we take it out of the circuit, and we are able to measure the resistance of a resistor. Now in this case the value is 39 ohms. Okay, so it is 39 ohms. Now let's say this is the resistor. Okay, there is an electric current I that is flowing through the resistor, and we have a certain amount of voltage across its terminals. Now what is Ohm's law and how we can verify it? It simply describes the relation between the voltage across the terminals of a resistor and the current it carries. So there is a certain voltage across the terminals of this resistor, and there is a current that is flowing through this resistor. So the relation between these two is actually Ohm's law. So this is what we need to come up with, what we need to verify. Okay, for me to actually study this Ohm's law or to verify this Ohm's law experimentally, I need to use one of these two circuits. So let's see. The first circuit, it consists of a DC power supply or a generator. So it's like a dry cell, but I can change the value of the voltage that is supplied by this dry cell. Okay, so it is something like that. I can change it. I can play with the voltage here. It consists of, let's say, a switch, a resistor, okay? And as we can see, we have a voltmeter that is connected in parallel across the resistor, so it reads the voltage across the resistor. And there is an ammeter in the circuit which reads the current that will be flowing through the resistor. Now, the second circuit that can be used as well, it consists of a dry cell, a resistor, and something called a rheostat. What is a rheostat? A rheostat is a resistor but of variable resistance. So I can change the resistance of this rheostat. Like I can use the value of 10 first, and let's say maybe 15, 20. So I can change the resistance of this. So in circuit 1, I can change the voltage across the dry cell. And in circuit 2, I can change the resistance of the rheostat. And in both cases, I will be monitoring the voltage across the resistor and the current that will be flowing through the resistor. So I will have a table with both of these values, and let's see if there will be a relation between them. So one of these circuits allows us to draw the characteristic current voltage of the resistor. So it is called characteristic current voltage. It's like the relation between the current and the voltage. In order to get the required relation that verifies Ohm's law. Now let's define a rheostat and a DC power supply before we move on with the experiment. So as we said, a rheostat is a resistor with variable resistance. So the resistance can be changed, okay, between two values, between 0 and a certain maximum value. And this is its symbol. This is how we actually symbolize it, okay? Now, as for the DC power supply, as we said, it is a battery but with variable voltage. It doesn't mean it's not a DC battery. It's still a DC power supply. It's a direct current. It is constant, but I manually can change this voltage that is supplied by this battery. Okay, so I can change the voltage, that's it, but it does not change on its own. It's still DC, okay? It's still constant. It still shows a flat line on an oscilloscope. It is still DC. Now, the symbol of it is simply the symbol of a dry cell, but with an arrow, just an inclined arrow like that, okay? Now, we will build this circuit in this simulation, which consists of a DC power supply, a resistor, an ammeter in the circuit to measure the current, and a voltmeter across the resistor. So yeah, just simply click on the simulation and let's get going. Okay, so this is the circuit that I built. So it consists of a, DC power supply, like a dry cell with a variable voltage that I can change, an ammeter right here, a resistor, a voltmeter across the resistor, and a switch. This is an open switch, and now this is a closed switch. So I will set the initial value of the voltage of the dry cell. It will be 0. Okay, so this is like the initial value. So what is the voltage across the resistor? What does it read? It reads 0. What is the current in the circuit? It is also 0. So the current is 0. We can write it down. The current is 0 and the voltage is 0 as well. Great. Now let's increase the voltage. Okay, so let's make it, let's make it 10 volt. Okay, so for 10 volt, I have the voltage across the resistor now is 10, and the current in the circuit is 1 amperes. Okay, let's increase the voltage across the dry cell. So let's try to make it 20. All right, so let's make it 20. Now the voltage across the resistor is 20 volts and the current that is flowing through the resistor is 2 amperes. Let's increase the voltage to 30 now. Okay, so the voltage across the resistor is 30 and the current that is flowing in the circuit is 3 amperes. And let's increase it again now to 40. So the voltage that is across the resistor is 40 and the current that is flowing through the resistor is 4 amperes. So this is the table, we filled it out. Okay, so yeah, this is what happened when the switch was open. The voltmeter and the ammeter, they both read 0. Okay, and then when we close the switch, each time we change the voltage across the DC generator, we measure the voltage across the resistor using a voltmeter and the current in the circuit using an ammeter. So this is what we did, and this is the table that we simply got. Now let's represent this table with a graph. We can simply draw the graph that shows the variation of U, the voltage, as a function of I, the current, the variation of Y axis as a function of X axis. So the I, the current, must be on the X axis and the voltage must be on the y-axis. Guys, it's always variation of y as a function of x, variation of y as a function of x. So it says as a function of I, it means I must be on the x-axis. Now, I did already draw the scale for it. Okay, so I have 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4. So but the best scale to take is every 1 centimeter is 0 0.1 amperes. And for the Y or for the voltage, every 1 centimeter represents 10 volt. Okay, so this is what I did. Now let's plot this graph. So the first point that I have is 0, 0. So this is actually like the abscissa and ordinate, right? The I is the abscissa, The U is the ordinate. So I can simply write it down. We write abscissa ordinate. Okay, so let's write it down. 0, 0, this is the first point. The second point is 0.110. The third point, 0.220. 0.3 30 and 0.4 40. Yalla, let's do them. So the first one is 0 0 0 0, so it's like the origin, it's right here. The second point is 0.110, 0.110, so it's this point. Third one, 0.220, so it's right here. Then 0.3 30, then 0.4 40. So I connect the dots. Okay, I'm gonna try to draw a straight line as straight as possible. So I connect the dots and I end up with a straight line that is passing through the origin. So this line, this obtained curve is called the characteristic current voltage of the resistor. This is what we call it. And it is a straight line that is passing through the origin. And you can see it has a positive slope, which means that it is an increasing straight line. So it increases. We can see that it increases. Okay, so it means that the slope of it is positive, and we're going to prove that. So we're going to find the slope of a straight line. How can we find the slope of a straight line? We usually take 2 points on the line. Okay, let's say the first point of abscissa, let's say 0.3, ordinate 30. The second one, abscissa 0.2, ordinate 20. And then the slope would be right? Y2 minus y1 over x2 minus x1. This is how we find the slope of a straight line. But since this curve is passing through the origin, which means I can take the first point, any point on this line, and the second point would be the origin, so which is 0, 0. So I can find the slope by simply writing y over x for this point. Okay, so the y for this point is 10 over x for this point, which is 0.1, and the answer would be 100 ohms. Okay, so this is the slope of the line. Now, what is this ratio? You can take any point on the curve and you would end up with the same slope because it's a straight line. It has one slope. So this ratio, U over I, okay, so it's U over I, right? 10, it is the voltage. 0.1, it is the current. So as if I'm saying U over I, it is a constant value. It has a constant value which is equal to R. What is R? It is the resistance of the resistor. So the slope is actually the resistance of the resistor. So the relation between U, I, and R is called Ohm's law. So now I know this relation. I know that U over I, the voltage across the resistor over the current that is flowing through the resistor equals to the resistance of the resistor. So this is the relation. It is called Ohm's law. So what is Ohm's law? Ohm's law, it is simply the voltage which is across the resistor equals to the resistance times the current that is flowing through the resistor, right? Because the relation that we got was U over I equals R. So U would be equals to I times R. All right, now let's take a look at this picture right here. It actually represents how a resistor works. So you can see the ohm right here. It is trying to resist the passage or the flowing of the amps in the circuit. Okay, now the volt is pushing this amp throughout the wires or the circuit, but the ohm is trying to resist it, is trying to stop its movement. Okay, so this is how a resistor works, and this is how, this is what we mean by resistance. Yeah, so this is the formula, and U represents the voltage across the terminals of the resistor. It is in volt. I is the current traversed through the resistor. It is in amperes. And R is the resistance, which is in ohm. So this formula, it reminds us of the famous triangle that we know, which is this one. All right, so from this triangle, I can get three formulas. It depends whether I'm trying to find the voltage, the resistance, or the current. Now remember, these are the units that must be used. Okay, so usually the current will be given in like milliamperes, so we must convert it to amperes for us to use this formula. So that is it for this week. I hope you guys understood it. So please try to solve the homework, okay? And it is like a direct application on what we solved today, what we explained today. So yeah, see you guys in the live Zoom. Take care and bye bye.